Okay, good afternoon, everyone, and welcome to a brand new week. So hopefully you enjoyed your weekend, you found some time to relax, even though alam ko deadline kahapon nung homework 3. And I guess almost everyone submitted their homeworks. There are just a couple of you who haven't submitted yet. But hopefully you already found your graded homework 3. Probably next meeting, I can say a word or two about that. Pero kalimutan ko yung pangako ko last week about homework 2 to say a couple of words about this and note some of the common errors or the common points for improvement for the previous homework. So number one, I really appreciated some of you who included a detailed proof or detailed explanation of the things of their answers for problem one. But I guess I said in one of our meetings that I don't need to see any explanation why your answers are that. Hindi ko lang siya nasulat, pero it is a nice habit that you develop na pag merong problem, nilalagay nyo lahat ng justification. So yeah, whenever I don't want the justification, I will say it verbally probably in the classes or isusulat ko siya in black and white para hindi na makadagdag dun sa kailangan yung gawin or isulat. Now, some common things that were done here in problem number one. So letter A, find the limit points of A. A bunch of you answered 0, 1, and 2. Probably because these are the most visible limit points of the set A. However, hindi lang si 0, si 1, at saka si 2. Because remember, for a function or for a number to be the limit point of a set, dapat kahit anong epsilon neighborhood around that set will contain an element of the set other than itself. So true enough, if you get 1, so i-plot natin yung set. So 0, 1, dito pala si 1, dito ko si 2. So 0, 1, union 1 to 2. And you're right. Any epsilon neighborhood around 0 will contain elements of the set. Kasi ang isang epsilon neighborhood around 0 looks like this. Okay, isang open interval centered at 0, laging merong element ng set A. Okay, also for 1 and for 2. But you forgot to include all those interior points. Kasi pag kumuha ko ng isang point na nasa loob ng say interval 0, 1, say 1/2, kahit anong gaano kaliit na epsilon neighborhood yung i-drawing ko, laging merong element yung set aside from 1/2. So that means 1/2 is also a limit point of the set A. So that means this is not enough to cover all the limit points. And actually, the limit points or the set of all limit points of A is a closed interval 0 to 2. That means lahat ng interior points at lahat ng nasa boundary ni A. Okay? And the answer to B follows directly from A dahil nakakita tayo ng elements na wala kay A na limit point, specifically 1 and 0. They are limit points of the set A, but they are not in the set A itself, so A is not a closed set. Then it is not open because there are elements of the set which has epsilon neighborhoods that are not properly contained in the set itself. So sabi pag open, dapat lahat ng elements merong epsilon neighborhood na nasa loob ng set. But look at the number 2. The number 2 is in the set, but if you draw an epsilon neighborhood around 2, however small it is, laging may masasakop tayo na nasa labas na ng set A. So that makes the set not open. And this is an example of a set that is neither closed nor open. Posible na isang set ay hindi open at hindi closed at the same time. Okay. D, does A contain any isolated points? Remember, an isolated point is a point that is not a limit point. So kasi pag limit point, sabi natin, accumulation point siya. Sa kanya, nagkukumpul-kumpol yung mga elements ng set. So, in contrary, kung isolated point siya, ibig sabihin nag-iisa siya. Pwede kang makakita ng isang epsilon neighborhood na walang ibang lamang element ni set A. So ibig sabihin, hindi siya limit point. And since the set is a subset of its derived set, so ibig sabihin wala siyang limit points. And A bar, you can just say A bar is 0, 2, or pwede kayo magpasikat, sabihin nyo na, oh, sir, alam ko to, ito ay A union A prime, tapos set A union yung 0 to 2, then you can say close interval 0 to 2. Okay, so that would be it. Now, I guess here my grading system is 0.4 for each item, all or nothing. So if you missed one, if you missed a little bit on the answers, then tanggal kagad yung 0.4. That makes it a total of 2. And then yung problem number 2 is worth 3 points. Now, I'm happy that almost all of you got no, I think all of you have the right idea how to proceed. Pero meron lang ilan on gumamit ng isang specific class of set A. They started their proof by saying that, okay, consider A is the open interval AB. Okay, so though your object A is still generic, pero hindi na siya kasing generic nung kailangan ko sa theorem. Kasi sa theorem, the theorem say nothing about the structure of A. All we know that A is a subset of the set of real numbers. Hindi sinabi kung si A ay open interval. Hindi sinabi kung siya ay closed interval. So true enough, you can show na, yeah, the boundary of A, which consists of the set containing A and B, will just be the intersection of the closure of A and the closure of A complement. Pero ang problema ay it should also hold for A's that are not open intervals. So, posibleng si A ay union ng mga open intervals or intersection ng mga open intervals. It could even be a discrete set. So, hindi necessary na set A. So, you could have begun your solution by considering an arbitrary set A because this statement is being claimed for all possible subsets of the set of real numbers. So, you can say let A be a subset of R, and you want to show two things. You want to show that A bar intersection A complement bar is a subset of the boundary of A, and the boundary of A is a subset of A bar intersection A complement bar. Okay? So ang atake dito sa proof, you get an arbitrary element of this set and show that it is in the boundary. Okay, and then on the other half of the proof, you will get an element of the boundary, and you want to show that that element, that generic element, also belongs to the intersection of the two closures. Okay. Now, dahil hindi natin alam ano yung itsura ni boundary of A, because it is what we are proving, okay? So, kailangan yung gamitin yung definition ng pagiging boundary. I-check nyo kung lahat ba ng epsilon neighborhood ni X will contain an element of A and an element of A complement, okay? So, medyo may subjectivity yung pag-grade ko sa problem number 2. I mean, aside from the technical content, I am also looking for how you wrote your solution, how you presented your solution. So you will get a 3 in problem 2 if you had the right idea, you had the correct, you used the correct logical tools, and then the correct definitions, you had the correct conclusions and whatnot. So basta maganda yung, hindi, tama yung technical content at maganda yung pagkaka-present, you get perfect 3. Okay. But if your idea is correct, technically it is correct, but it doesn't read well. I mean, nahirapan akong i-decipher saan nanggagaling yung mga arguments nyo, then probably I'll give you something between 90 to 100%. So lagi ako nag-iisip in terms of percentages. So kung feeling ko 90% lang, kasi hindi ganun magkaganda yung flow o medyo watak-watak yung idea, so bibigyan ko kayo ng 2.7 over 3. Kaya makikita nyo may mga decimals yung mga scores nyo. And then, kung meron lang naman mga maliliit na butas or maliliit na typo errors, I mean, yung typo errors, pinalalampas ko na yung grammar error, o kaya yung wrong spelling, yung mga ganun. Pero if merong symbol na mali, like I think there's some of you who wrote A bar complement. A bar complement is not necessarily the same as A complement bar. So be careful sa pagsulat ng symbols. So if I see in your proof na though ito yung naisulat nyo, pero what you meant and what you used in the rest of your proof is this set, then probably I'll just give you 1% deduction or 2% or 3% deduction for those very minor errors. Okay? Pero medyo malaking chunk yung mawawala if you have the right idea but wrong logical foundation. So kahit na halimbawa nag-prove kayo using the open interval AB, and then tama yung pagkaka-prove nyo, but the problem there is you were not able to satisfy what I want you to prove. Because you have only proven that the statement is true for open intervals, but not for arbitrary subsets of R. For those cases, I gave 60%. So you get 1.8 over 3, which is passing. Kasi na-illustrate nyo naman yung tamang paggamit ng Math 155 concepts. However, it's quite limited kasi hindi nyo na-cover lahat ng possibilities. And actually, the proof for general cases is a little bit more involved rather than using intervals. Kasi madaling sa intervals kasi makukuha nyo yung closure niya, makukuha nyo yung explicit form para sa intersection, tas para sa closure ng intersection at para dun sa boundary. Okay? So I hope you understand. So if you were able to use the Math 155 concepts, you have a very valid attempt, maganda yung pagkaka-present, yun nga lang merong mga logical flaws. So perhaps you'll get between 50 to 70%. And then if you have an attempt, tapos hindi naman, hindi siya nakaabot dun sa minimum applications of Math 155 concepts that I'm looking for, then probably I'll give you between 10 and 30%. So, yeah, yun yung pinaka-idea ko about giving grades for proofs. Okay? Now, on Friday, I'll give you the first problem set. And I want to warn you guys, ginamit ko warn, hindi naman sa pananakot, pero sige na nga, tatakutin ko na kayo. Medyo mas matinding isipan kaysa sa homeworks. So I already finished writing the problems. There are 5 problems in the homework, in the problem set. So sa problem set, 5 items. Problem number 1 is essay type. So may papa-explain lang ako na concept sa inyo. Pag nagpapa-explain ako ng concept, gusto ko yung how you interpret it or how will you say it to a layman? Paano nyo ikukwento halimbawa yung idea ng open set o ng interior point ng isang set or limit point ng isang set? Paano nyo siya ikukwento to a non-specialist? So I don't expect you to quote the definitions in the modules or kumuha ng highfalutin words from somewhere else. I want to see how you interpret it. And kung kayo yung teacher, paano nyo siya ituturo? Ano yung interpretation nyo about that particular concept that I will ask you to explain in problem number 1. Okay? And then, ano pa nga ba yun? There's one problem. One problem that is like problem 1 in this homework. So meron akong ang instruction dun sa isang problem na to ay give a set E, subset of R, that satisfies the following conditions. So halimbawa, letter A, magbigay ka ng set E na halimbawa na isang closed set na kino-contain yung last 5 digits ng student number mo. So bahala kayong mag-imbento ng example basta nasa-satisfy ni set E yung nasa condition A. Hindi nyo na kailangan ng paliwanag. So pag nagbigay kayo ng example, I'll just check kung na-satisfy nyo ba yung gusto kong condition. Halimbawa sa part B, magbigay ka naman ng set E ng closure niya ay sarili niya. Okay? Or ang closure niya ay may laman na ibang elements other than elements of itself. Para mga ganun. So, meron yatang 5 akong hiningi na examples. Tapos, yun yung kailangan yung ibigay. Okay? And then I guess the rest are proving questions. So meron pang tatlong proving questions. And each of the numbered items would be worth 10 points. So over 50 yung problem set. So you can get a maximum of 50 over 50. So 10 points each. Tapos gagawan ko siya ng hiwa-hiwalay na submission bin sa Canvas. So para pagtapos na kayo sa problem 1, upload nyo na siya para ma-checkan ko na siya kagad. Natapos kayo sa problem 4, kahit hindi nyo patapos yung 2 and 3, upload nyo na rin si problem 4. Okay? Now, this would be longer than the homework. So you have how many days? Friday, Saturday, Sunday, Monday, Tuesday, Wednesday. So you have 6 days to finish the homework, the problem set, including the weekends. So kung ayaw nyo mag-work ng Sunday, then you must allot or you must be able to answer one problem per day. So kaya siguro medyo kailangan yung pagplanuhan yung weekend nyo saka yung simula ng next week. So if you have other requirements in other classes, try to finish them this week para medyo free na kayo next time. But I saw to it na siguro one problem a day is enough for you to finish it on time. I don't know, siguro typically you will need 1 to 3 hours to think about the answer to a certain problem, to one item. So devote 3 hours per day to finish one problem a day. Then you will be in a good shape to submit it on Wednesday next week. All right. So any questions about that? Or gusto nyo ba gawin ko na lang 4 tapos choose 4 among the 5? Gusto nyo ba yun?
Gusto, sir.
Thank you, Donnie. Pasalamat ko kayo kay Donnie kasi siya yung sumagot. So, yeah. Sige, gagawin kong choose 4 out of 5. Para sige. Kung 4 out of 5, 4 out of 6. So, 2/3 of a problem dapat a day yung magawa nyo. So, sige. Pero ibibigay ko na yung 5 tanong. Yung 5 tanong, pili lang kayo ng 4. Bawal sumobra ha. So, bawal mag-over 40. So, gagawin natin siyang 40 over 40. 5 problems, 10 points each. Submit only 4 out of the 5. So pwede kayong pumili kung ano yung pinakamadali sa tingin nyo na 4. Iwan nyo yung isa. Okay? So yeah, I think that is better. So I'll give you 5 questions, choose 4, and then submit 4. All right? Okay. Now, let's see. Other concerns about the problem set? Ito na yung time niya para mag-haggle about the problem set because after this, I will not entertain any more appeals or any more pagmamakaawa. So, ito na yung last chance. Is this good for everyone? Wala na ba kayong requests? You can use anything. Pwede nyo i-search sa internet kung mahanap nyo siya. Kung mahanap nyo man siya, good luck. Tapos, pwede kayo magtanungan. You can work in groups. Ang request ko lang, pag nag-work kayo in groups, lagay niyo yung pangalan ng members dun sa, at least isa dun sa mga items. Pwede niyo sabihin, Sir, I work with student A, student B, and student C for this particular problem. Or, I work with this classmates of mine for all the items in the problem set. So, okay lang din naman yun sa akin. Basta as long as you can, kaya nyo pa rin panindigan yung academic integrity declaration that you submitted to me at the beginning of the class. And try to understand kung ano yung mga sinulat nyo, right? Huwag kayong papayag na sa study group nyo ay matatapos na kapag nasulat nyo na yung sagot. Okay, so sana intindihin nyo yung isusulat nyo on paper. Yes, Donnie, you have your question?
Sir, yung mga sagot po sa problem set, sa pen and paper po, hindi po pwede na parang ganito po sa, pwede po sa tablet or notes.
Yeah, pwede. I don't care how you write it, so basta nababasa ko, so okay lang. So kung gusto yung pen and paper, then pipicturean, okay. kung rich kid naman kayo, you have a tablet, so you can also use your tablet and so on. Kung pasikat kayo at pabibo, pwede rin naman naka-latex or naka-word, the better. Pero gusto ko ba yung naka-latex o naka-word? Baka kasi copy-paste lang no? So, yeah, I don't care. So, kayo nang bahala. I trust you naman. So, yeah. Basta isasabit nyo via Canvas. Para madali ko siyang matchekan. Okay? Any other questions? Wala na? Okay, so if not, then let's go back to module 2 or to lecture notes 2. And oh yeah, I read your comments about the comments in homework 3. So thank you for all your kind words. I really appreciate it. And then thank you also for pointing out some points for improvement. A common comment is to give more examples. I don't know, I'm not sure what type of examples you are referring to. Pero siguro ang inisip ko yung specific examples. Halimbawa sa pagkukuha ng limit ng sequence o pagpo-prove ng limit ng sequence ay ganito. Or examples ng specific examples ng closed sets, ng open sets, and so on. Yeah, I'll try to do my best and give you more concrete examples for this definitions. Pero my idea for an advanced calculus class, and perhaps this is a good start when you go to major math courses. Tama nga ba juniors kayo, no? So probably you were used to doing, say, Math 36, Math 38 stuff, wherein you're really bombarded with lots of specific examples. Kasi isang konsepto, gusto lang makita dun sa lower math courses na na-apply nyo siya. Okay? So sort of mechanical yung nangyayari. Pero once you go to the 100 level courses, the idea is we're going to work with abstractions. So yung specific examples, sila lang kumbaga yung magiging stepping stone natin to understand what these abstract concepts are about. So basically, we have a definition, and then we will just look at specific examples so that to create a picture in our heads what those definitions mean. I'll try to give specific examples or I'll draw something just to illustrate what it means. Pero ang idea kasi natin ay we want to work with abstractions and use these definitions in order to prove theorems. So parang nagiging example na pag nasa 100 math courses na kayo, ay yung mga theorems. Paano mag-prove using definitions and using previous theorems and other axioms in order to prove statements. So really, our bread and butter here is to proving theorems. That's why you will notice na hindi ako masyado nagbibigay ng concrete examples, diretso kagad sa proving things. And I usually focus on how to write the proofs because, again, that is the expectation from a 100 level course. But I understand your clamor. Baka naman kasi kailangan pa ng mas maraming examples para mabuo yung mental picture ng mga abstract concepts. Because, yeah, you're right. It's hard to write the proof if you really don't understand what the objects of the proofs are. So kailangan maintindihan muna natin ano pa yung mga open sets, mga closed sets, ano yung mga sequences, so that mas madaling magsulat ng proof about them. And yeah, perhaps starting today na nga ba, or probably next time, I'll try to give more concrete examples just to give us a more tangible example or a tangible illustration of these abstract concepts. Okay, so last time we talked about limit theorems. So we went on talking about the algebraic and order limit theorems, as well as the squeeze theorem. I think that's where we stopped last time. So kung mapapansin nyo, again, hindi na ako nagbigay ng examples paano yung na-apply yung mga theorems na yun. Kasi napagdaanan na natin yan sa lower 30 series, right? Sa Math 30 series. So, and ang idea ngayon ay nire-reconstruct natin sila as an abstract tool to provide proofs to larger and bigger results. So for this week, we'll try to tackle the major theorems regarding limits of sequences, because these major theorems play a role into the development of the set of real numbers. Kasi we will see later na itong mga big theorems, so itong mga major theorems na to, they are equivalent to the notion of the completeness of the set of real numbers. So these theorems are big because even though they are for sequences, but they are closely related, or actually they are twins to the completeness action. Meaning we can replace the completeness action, which is, I think ang inelect natin na completeness action is the LUB property. Now, pwede nating palitan yung LUB property by one of these major theorems that will serve as our completeness axioms, and yet we will be able to recover the calculus that we know from Math 30 series. Okay? So kaya tawag sa kanila ay major theorems. But before that, syempre, marami pa tayong pagdadaanan ng mga konsepto bago tayo makapunta dun sa mga major theorems na yun. And one of them is the idea of a subsequence, right? And that's what definition 5 is about. So first, we consider a sequence, A sub n. And then we say that this sequence, A sub n sub k, is a subsequence of an if nk is a function from k to nk. So nk is really a function from the set of natural numbers to itself, such that n sub k plus 1 is greater than n sub k. So ito yung napaka-technical na definition ng subsequence. Meron kang sequence. Pwede kang bumuo ng subsequence galing dun sa sequence na yun by picking certain elements of that sequence. So pipili lang ako dito sa mga an, sino yung ilalagay ko sa subsequence. So para siyang subset. Okay? Pero kakaibang subset siya. Kakaiba siyang subset so that the ordering of the elements are preserved. So, di ba, alam natin ang sequence ay isang ordered list. So, pag kukuha ko ng subsequence, ibig sabihin, kukuha lang ako ng mga elements mula dun sa original sequence. Tapos, magpo-form ako ng panibagong sequence in such a way na kung nauna yung isang element dun sa unang listahan, dun sa original sequence, dapat mauuna din siya doon sa subsequence. And that's what this very technical and lengthy phrase here is telling us. Subset siya ng isang sequence na naprepreserve yung order. So for instance, nag-attempt ako ditong mag-drawing, right? So, halimbawa naka-plot, ito yung mga elements ng aking sequence. So A1, A2, A3 until AN. So ito yung mga ANs ko. Kung gusto kong bumuo ng isang subsequence ni A, and I call it A sub n sub k, ibig sabihin, pipili lang ako mula dun sa original list. So pwede kong kunin halimbawa si A1. Ilalagay ko siya dun sa list. Tapos kukunin ko si A4. Tapos kukunin ko si A8. Tapos kukunin ko si, say, A12. And so on. Kaya lang, ang sabi natin, dapat na-preserve yung order. So, kung ito na yung first 4 elements na napili ko, kung gusto kong makakuha ng subsequence, hindi ko na pwedeng isingat si A7 after A12. Because here, this is the 12th element in the previous list, and yet it precedes the 7th element of the original list. So, hindi na na-preserve yung ordering. So kung nauna siya dun sa original sequence, dapat nauuna pa rin siya dun sa subsequence. Ito yung sinasabi na yung n sub k gives us a function that preserves the order on the subscript. So ito yung n1. So dito ang n1, ang n sub 1 ay si 1, ang n sub 2 ay si 4, ang n sub 3 ay si 8, ang n sub 12, ang n sub 4 ay si 12. Kasi yung unang element dun sa subsequence ay yung unang element dun sa original sequence. Yung second element dun sa subsequence, kaya siya yung may subscript na n sub 2, ay yung pang-apat na element dun sa original sequence. A sub n sub 3, yung pangatlong element ng subsequence, ay yung pang-walong element, A sub 8, mula dun sa original sequence. So basically, we are picking elements from the original sequence na kapag ka nakapili ka na, hindi ka na pwedeng bumalik pa kaliwa. So pag pumipili ka, laging mula sa kaliwa pa kanan, and you cannot go back to the left, right? So yun yung idea ng subsequence. Pili ka lang ng elements pero hindi ka na pwedeng lumingon sa pinanggalingan. So dapat forward-looking ka palagi sa pagkuha ng elements ng subsequence. Okay? Does that make sense? At least intuitively, yung konsepto ng sequence. So hindi lang siya basta subset, dapat na-preserve yung order. Kung nauna siya sa original sequence, dapat mauna siya dun sa subsequence. Okay? Now, let's probably look at tangible examples. Okay. Okay, example 2. So, meron tayong, siguro example 1 muna. Though medyo abstract yung example 1. So, kung meron kang A sub n, pwede mong kunin yung subsequence consisting of those elements with odd subscripts. So, yung sequence A sub 2 sub k plus 1, ibig sabihin when k is equal to 1, meron kang A, actually mali to. Gawin nating minus 1. A sub n, A sub 2k minus 1. Para when k is equal to 1, makukuha natin yung unang element ng subsequence. So when k is equal to 1, we get A sub 2 times 1 minus 1, so A1. And then A3, A5, A7, and so on. This is a valid subsequence kasi kung makikita niyo yung mga subscripts nung nandun sa subsequence, increasing order pa rin. Unang element ng subsequence is the first element in the original sequence. The second term is the third term in the original sequence. The third term is the fifth, and so on. Increasing lagi yung order. In the same manner, a classic subsequence is that subsequence consisting of those with even subscripts. So meaning you start with A2, you go with A4, A6, A8, A10, and A12. So this is a valid subsequence. But if for some reason you put A100 here after A2, then this won't qualify as a subsequence anymore because you have 100 element of the original list here being a precedent to the fourth element of the original list. Bawal yon. Tama? Kasi dapat na-preserve natin yung ordering. Okay? Now, some more examples. This one. The sequence -1 to the power n. So if we will list the first few elements of this sequence, we'll get -1, and then 1, -1, 1, -1, and so on. So we know that they will just alternate signs, or they will just the terms will just oscillate between -1 and 1. And then I can get -1, then another -1, another -1, and so on. So I can get a subsequence consisting purely of -1s. Kasi yung mga -1s sila yung nasa odd positions. And if I will just copy paste those from the odd positions without messing up the order, then I'll get a valid subsequence. And then also you can harvest the even terms, or the terms in the even positions, and get the sequence purely of ones. And what can we say about this sequence and its subsequences? Well, this sequence we know is divergent. Tama, na-prove na natin na divergent siya. Hindi siya nagko-converge to a certain value. I think we even wrote a proof for that. And one of your classmates said na, sir, isa yung example ng bounded sequence na walang limit or na divergent, which is right, okay? But look at this. This is a bounded sequence that though is not convergent, meron tayong na-form na dalawang subsequences. And these two subsequences being constants, or being a constant subsequence, ay convergent. So parang sa number 2, it suggests na, kahit pala divergent yung isang sequence, posible tayong makahanap ng convergent subsequence by just picking the subsequences in a nice and intelligent manner, right? Nakabuo tayo ng convergent subsequence niya. Excuse me, guys. Okay. Now, let's try problem 3, or example 3. In example 3, we have the sequence 1, 1/2, 1/3, 1/4, and 1/5. So this and this are said to be valid subsequences because, again, in general, this is just 1 over n. So the larger the denominator is, the farther away it is in the list. All right. So intuitively, you can say, these two guys are subsequences. All right. But the third one is not a subsequence. Bakit hindi siya subsequence? Anyone? Any volunteers? Bakit hindi subsequence? Yung 1/10, 1/5, 1 over 100, 1 over 50, and so on. Oh, yes, Donnie?
Sir, yung order po.
Okay. I guess I got what you said, though medyo choppy na naman yung incoming audio ko. But yeah, you're right, Donnie. Kasi yung order hindi na preserved. Specifically, 1/10 came earlier in the subsequence than 1/5. And yet in the original list, 1/5 should come first before 1/10. Okay, so hindi na preserve yung order, so hindi siya subsequence. Okay? Now, spoiler alert, subsequences will play a central role in one of the major theorems that we will tackle. So, tandaan niyo yung subsequences. Okay? Now, let's see. This is our first theorem involving subsequences. So, theorem 2.6. So, we consider a sequence A sub n, okay? And then it says that the following are equivalent. So, statement A, the sequence is convergent and it has a limit A. Statement B, every subsequence A sub n sub k converges to A in R. And thirdly, the subsequences form with even and odd positions both converge to A in R. Now, the thing about this theorem, sinasabi niya na equivalent itong tatlong statements na to. If you look at this first statement, okay, I think this is not provable for a generic AN. Kasi wala kang ibang premise. Alam mo lang meron kang sequence, tapos ang sinasabi ng statement A, convergent siya to A in R. Pero pag sinabi mo na this statement is equivalent to, say, statement B, then you can prove one by assuming the other. So, ang ibig sabihin nito, si A, if implies B, and B implies A. Kasi equivalent silang dalawa. So if you want to prove the equivalence of statements A and B, kailangan ipakita mo na pag inassume si A ay totoo, dapat magpa-follow si B. At kapag inassume na totoo si B, dapat maging totoo si A. So yung isang statement nagiging assumption or nagiging premise, yung kabilang statement nagiging conclusion. Okay? So ibig sabihin, gagamitin natin si A para ma-prove si B and vice versa. Kaya lang sabi rito, silang tatlo ay equivalent. So ibig sabihin si B ay equivalent din dapat kay A. So that is equivalent to two theorems. First is kay C. B implying C and C implying B. Okay. And then si A and C are also equivalent. So that means A implies C and C implies A. So this theorem actually is a set of 6 theorems in disguise. So 6 yung kailangan nating i-prove if we will just go through the definition of being equivalent. Okay? So ganun nagpo-prove ng statements na equivalent sa isa't isa. Assume one, show the other, and vice versa. Kaya lang dito tatlo sila, so kailangan nating i-prove itong 6 na to. But we can use a shortcut. Pwede tayong gumawa ng isang circular route in order to prove the equivalence. I'm saying, let's try to prove A. Let's try to prove that A implies B. Tapos pakita natin na si B implies C. And then lastly, prove natin na si C i-imply niya si A. So parang nagkakaroon ka ng cycle. So if we will be able to show that A implies B, then that's good. We'll show that B implies C. and then C implies A. So parang tatlo lang yung pinrove natin. Meron tayong mga hindi na kailangang i-prove. Halimbawa, yung B implying A, hindi ko na siya kailangang i-prove. Kasi gusto mo ipakita si B implying A, di ba? But B implies C, and yet C implies A. So by hypothetical syllogism, B will imply A. So nakatipid tayo ng isa. Hindi na natin to kailangang i-prove. Similarly, we don't need to prove that C implies B and A implies C kasi we can just make use of hypothetical syllogism. So that reduces the number of conditional statements that we need to prove from 6 down to 3. Okay. Now let's try to prove it. Okay. Sige, try na lang muna nating basahin yung theorem. Okay. Kasi nandito na naman siya. Oh, before I prove this, I need remark 4. Punta natin yung remark 4. Okay, there. We can show by induction that n sub k is greater than k, greater than or equal to k. Okay. Now, intuitively, madali ito makita. Kasi ano nga si k? Si k ay yung subscript dun sa original sequence. Si n sub k, siya yung subscript, pang k na subscript dun sa original, dun sa subsequence. So, kung babalikan natin yung drawing natin kanina, ang n1 ko ay si 1, so ito yung nk, ito yung k. So, si n1 ay equal kay 1, definitely si 1 ay mas malaki, ay greater than or equal kay 1. Okay. Si n2, baliktad pala. Ito yung nk, sorry. Ito yung mismong nk, tapos ito yung k. First, second, third, fourth. Okay. So yung n1, yung unang subscript dun sa subsequence ay equal kay 1, equal siya dun sa unang subscript kay original sequence. Yung pangalawang subscript dun sa original sequence ay si 2. Pero yung pangalawang subscript sa subsequence ay si 4. Yung pangatlong subscript kay original sequence ay 3. Pero yung pangatlong subscript kay subsequence ay 8. So definitely here we see that n sub k is really greater than k or greater than or equal to k. Mas malaki lagi yung corresponding subscript dun sa subsequence. And again, you can prove that by induction. Tingnan nga natin kung madali yun. Okay. So ito yung assumption natin. Definitely, n1 is greater than or equal to 1. Kasi ito yung minimum subscript number. So definitely greater than or equal si n1 kay 1. Kasi si 1 yung simula, pinakamaliit na posibleng subscript. So that's the basis of induction. Then if we will assume that n sub k is greater than or equal to k, we want to show that n sub k plus 1 is greater than k plus 1 para mabuo natin yung proof by induction, right? Pero ano bang alam natin? Alam natin na yung n sub k plus 1 ay mas malaki kay nk. Kasi ito yung sumunod na subscript kay nk. So since n sub k plus 1 and n sub k are both integers, right? So ibig sabihin yung difference nila ay greater than 1. So that means n sub k plus 1 minus 1 is greater than or equal to n sub k. So making n sub k plus 1 greater than or equal to n sub k plus 1 sa taas. Okay? Now, our hypothesis of induction is this. Okay? Ito yung ina-assume natin na totoo. Gusto nating mapalabas ito. Okay? So now, how can we do that? Well, I can add 1 to both sides. So I'll have n sub k plus 1 greater than or equal to k plus 1. Alright? So ito ang gusto kong target. Magkaroon ng n sub k plus 1. Oh, but look at this. N sub k plus 1 sa labas ay mas maliit kesa kay n sub k plus 1. So pwede ko itong kunin as an upper bound here. And that completes the proof. We have shown that k plus 1 is greater than or equal to, or is less than or equal to n sub k plus 1. So really, yung nk mas malaki or equal kay k. Is this making sense? Parang napaka-basic, no? Pero kailangan pa talaga nating i-prove na totoo siya para lang makumbinsi tayo. Okay. Now, to our main course, try nating i-prove to. Excuse me again. Okay. Now, yun yung strategy ko. I-prove na A implies B, B implies C, at saka C implies A. Umpisa natin sa A implies B. So A implies B. We will assume that the sequence is convergent to A, and we want to show that every subsequence converges to A in R. Ibig sabihin, kung convergent yung sequence, lahat ng subsequence niya magko-converge dapat kay A to the same limit. Now, let's look at the proof. Basahin natin. Okay. So this is the assumption. This is statement A. Siya yung premise. I-assume natin na convergent si A yan, and it converges to A. Then by definition of convergence, for any epsilon greater than 0, we can find a capital N such that for all little n greater than or equal to capital N, A sub n minus A has absolute value less than epsilon. Okay? Nothing fancy about that. We just wrote down what convergence means. Okay? And then we will let K be a number greater than or equal to N. So, ibig sabihin, meron na tayong nakuhang lower bound kay N. Right? Lower bound kay little n. After that lower bound capital N, totoo na lagi itong inequality na to. Alright? Pero I will choose a number k as that is larger than n. Remember, itong inequality na to nagwo-work sa lahat ng malalaking little n. In fact, sa lahat ng little n na mas malaki kay capital N. Alright? So, I will choose a number k na mas malaki kay capital N. So, ibig sabihin, simula kay capital N, pag nandito na yung subscript number mo, totoo na yung inequality. Kukuha ko ng little k. Si k halimbawa nandito. So, definitely, nag-hold sa kanya yung inequality. So, supposedly, magkakaroon na ng ak minus a is less than epsilon. Okay? But from remark 4, we knew that n sub k is still larger than k, right? Yun yung kapuprove lang natin by induction. So si n sub k, which is the subscript we are using for the subsequence, ay mas malaki kay k. Si k mas malaki kay capital N. So ibig sabihin si nk mas malaki kay n. So ibig sabihin nag-hold yung inequality para kay nk. So that means I can replace little n by little n sub k. Kasi si little n sub k ay mas malaki kay capital N. And thus, we get this inequality. Okay? And what do we have now? We have, for any epsilon greater than 0, there exists a k, right, which is a natural number, such that for all n sub k greater than or equal to k, totoo tong inequality na to. But if you remember, that is exactly the definition of convergence. So here we can say, therefore, a sub n sub k converges to the same limit a, right? By definition of convergence. So ang ibig sabihin lang ng equivalent nitong statement na to, A implying B, kapag ka-convergent yung sequence, kahit anong kunin mong subsequence niya, convergent pa rin. At nagko-converge siya sa parehas na value. Which actually makes sense kasi Habang lumalayo ka sa listahan, kung convergent yung original sequence, ibig sabihin palapit ka ng palapit dun sa limit L. Halimbawa, nandito yung limit L. Pag palaki ng palaki yung subscript, palapit ka ng palapit kay limit L. Pero remember, yung subsequence, pumipili ka lang naman ng mga elements dun sa listahan na na-preserve yung order. So habang lumalaki yung subscript dun sa subsequence, ibig sabihin ng pinipili mo yung mga palapit ng palapit kay capital L, which is the limit of the original sequence. So indeed, we don't have any choice but to accept na dun siya talaga magko-converge dun sa same limit. Okay? So if your sequence is convergent, then automatically it converges to the same, any subsequence of it will converge to the same limit. Okay? Is that clear? Okay, thank you. And then B implying C daw ay obvious. Bakit obvious yung B implying C? Sige nga. Ito yung mga nakakatakot sa textbooks. Pag sinabi na nung book na clearly or obviously, tapos hindi mo maisip, no? Parang nakakababa ng tingin sa sarili. But, yeah. Bakit kaya nasabi na obvious yung statement, yung B implying C? Anyone? Basahin nyo lang ano yung statement B at ano yung statement C. So, bakit obvious? Oh, yes. Dan Kennedy?
Sir, kasi po yung B, sinasabi niya po na every subsequence converges to A. So it follows po na kahit po yung subsequence man ay even yung even terms po or odd terms, magko-converge pa rin po siya sa A. So parang from general term po na dineduce lang into something specific yung B to C.
Okay, thank you, Dan Kennedy. That's perfect. So, sabi ng B, sa lahat ng subsequences, i-assume mo na lahat ng subsequence nagko-converge kay A. Pero tingnan niyo yung sa C. Ito ay isang subsequence, isang specific subsequence. This one is another specific subsequence. Pero by virtue of the universally quantified statement in part B, ibig sabihin dapat itong dalawa na to ay magko-converge din kay A. And so that is obvious. Tama? And so we're left with C implying A para ma-close natin yung circle, right? A implying B, B implying C. So last step, prove that C implies A. Pero baligtad yung arrow. Sorry. Typo lang yan. C implying A, yung gusto nating pangkompleto dun sa proof para makompleto natin yung cycle. Alright? So what is that? So we will assume that the subsequence formed by the even terms and the subsequence formed by the odd terms both converge to A and R. And then we want to use this in order to show that A sub n is convergent to A. Right? Yun yung gusto natin pakita. AN converges to A, knowing only that the subsequence of even and odd terms both converge to A. All right. Now, burahin ko muna ito. So dahil ang assumption natin, si A sub 2k ay convergent. So ibig sabihin, for any epsilon greater than 0, there will exist an n1 in n such that any little n greater than or equal to n1, yung A sub 2n minus A, kasi ito yung pinapatungkulan natin na sequence, ay nagko-converge kay A. Alright? Dapat totoo itong inequality na to. And then in the same manner, for the same given epsilon, we can always find a capital N2 such that when little n is greater than n sub 2, then A sub 2n minus 1 minus A will have absolute value less than epsilon. So we just apply the definition of convergence, right, to a specific real number, right? So simula kay n1, pag kinuha mo yung mga even terms after n sub 1, magko-converge kay A. Pag kinuha mo lahat ng odd terms after n2, nagko-converge kay A. And then kunin mo daw yung maximum ng 2n sub 1 at saka minus 2 sub n minus 1. So I think we can find a smaller value for capital N, but this maximum will work. So kunin natin yung mas malaki sa kanilang dalawa. And so if that is true, then capital N will be larger than 2n1, and capital N will be larger than 2 sub n minus 1. So ibig sabihin, sa lahat ng n na mas malaki kay n, correct? Pero pag si little n mas malaki kay n, ibig sabihin, nag-hold itong dalawang inequality na to. So ibig sabihin, si a sub n minus a ay mas maliit din kay epsilon. Kasi dito kinumpleto lang natin yung pinagsama lang natin yung mga dalawang subscripts. So ito ay nagiging true lang kapag si little n ay mas malaki na kay n1. Ito ay nagiging totoo lang kapag si little n si 2n minus 1 ay mas malaki kay capital N2. So kunin ko yung mas malaki dun sa dalawang lower bounds, ibig sabihin magiging totoo na siya sa lahat, mapa-even or mapa-odd man yung subscript. And so that means a sub n will converge to the number a. And hence proving that C implies A. Dahil na-prove na natin na A implies B implies C, at saka C implies A, then we have proven the equivalence of the three statements. Okay? All right, so let's see. Okay, now we will introduce another divergence criterion here, which will give us a nice sufficient condition kung kailan natin pwedeng sabihin na divergent kagad yung isang sequence. Remember, we already have one divergence criterion from before. Sabi natin siya ay divergent kapag hindi siya bounded, right? Because we know that a convergent series is always bounded. So if it is not bounded, then automatically the sequence is divergent. Now, this one is, I think, born out of the equivalent statements we have seen earlier. And sabi rito, if you have two or more subsequences converging to two different limits, then the original sequence diverges. So parang ano lang to, parang hindi lang pala parang contrapositive to, no? Isa din sa mga statements kanina. Remember, if AN converges to A, then any subsequence converges to A. Right? Ito yung A implying B. Kapag convergent yung sequence, kahit anong subsequence niya, magko-converge to the same value. Right? Pag kinuha natin yung contrapositive niya, so ito ay para sa lahat ng subsequence, for all subsequence. So ito ay false kapag nakakita ka ng dalawang subsequences na iba yung limit. Ang i-imply niya yung negation ng precedent. So ibig sabihin, hindi nagko-converge si AN. Right? So that makes having two or more subsequences converging to two different limits enough to conclude that the sequence is divergent. Okay? And this is one nice example. Another way to prove that this sequence is divergent. Bakit siya divergent? Pwede kang mag-epsilon n definition para ma-prove to like what we did last time. Pero alternatively, I can use corollary 2.1. Kunin ko yung sequence consisting of the odd terms. Ito yung nakita nating example kanina, sequence ng lahat ng negative ones. And this will converge to negative 1 kasi sequence lang siya ng mga negative ones. Pag kinuha ko naman yung even subsequence, puro ones naman yung laman niya. And this is a constant list of ones, therefore it must converge to 1. And here we have seen two subsequences converging to two different real numbers. So this is enough to conclude that the original sequence is divergent. Because again, we have found two different subsequences having two different limits. Okay. So probably one more example. Let's see. One. So example, if this is my AN. Sige, isip tayo ng maganda. Say 1, 3.9, 2.1, negative 1, 1, 3.99, 2.01, negative 1, 1, 3.999, 2.001, negative 1, and the pattern goes on. Okay? Paano ko mapuprove na ito ay divergent? Of course, looking at the pattern seems to, there seems to be a pattern that will repeat. So, kaya lang hindi clear kung paano ko ito mapuprove via definition. So again, I can take advantage of the divergence criterion we have established by constructing two sequences having different limits. So posible na ang kunin kong unang subsequence ay 1, 1, 1, 1, and so on. Kinuha ko to, kukunin ko to, then kukunin ko yung nandito kasi si negative 1 always followed by 1, and so on. And this converges to 1. I can get also negative 1, negative 1, negative 1. Yung mga negative 1s naman ang i-harvest ko, right? And I know there would be a negative 1 here if the pattern continues. And that subsequence will converge to 1. To negative 1. So two subsequences having two different limits, hindi na siya kagad convergent. And I guess this is much easier than trying to use the definition kasi parang mahirap i-generalize yung formula para sa A sub n dito, which is vital if you want to use an epsilon n definition. Okay, question. Can you give me another subsequence of this sequence na nagko-converge pero sa isang number different from 1 and negative 1? Ayaw niyan lumit. Sige nga. Can you give me another subsequence? Or kailangan niyo pa ba makita yung mga susunod na terms? So, sige. Habang nag-iisip kayo, dagdagan ko siya ng konti. Baka makatulong. 1, 3.9999, and then 2.0001, and then negative 1, 1, and so on. Okay? Can anyone give me another subsequence? Na convergent, pero nagko-converge sa number aside from 1 and negative 1. Yeah, I appreciate it, Donnie, pero tingnan ko muna kung may iba na magvo-volunteer. Anyone? Aside from Donnie or sino pa ba yung nakapag-recite na? Dan Kennedy. So, oh yes, go Carlo.
Sir, if you harvest yung mga 3 point something, it converges to 4.
Great, thank you, Carlo. So if you go by the pattern, so harvest ko raw yung mga 3 point something. So 3.9 yung una, and then yung sumunod ay ito, 3.99. Again, I am very careful as to maintain the order. Then 3.999. And then 3.9999, and so on. And if the pattern continues, parami lamang ng parami yung mga nines, right? Dun sa decimal representation. So this will converge to 4. Okay. So thank you. That's correct. There's another easy one. Anyone aside from Donnie, Carlo, or Dan Kennedy? Oh yes, Mary. Yeah, Ray.
Yung ano po, sir, yung 2.1, 2.01, 2.001, and so on po, nagko-converge po siya sa 2.
Great. So this is another subsequence, again, I was very careful to maintain the order of the terms, and this converges to 2. So we have found at least 4 subsequences that are convergent, but they converge to different values. So that makes this sequence, the original sequence, divergent. Okay? Pero pag nakakita kayo ng dalawang subsequence na magkaiba yung limit, enough na yon to conclude divergence. Medyo nagpasikat lang tayo dito at naghanap ng dalawa pang magkaibang subsequences. Okay. Now, I guess we'll stop here in the topic of infinite limits. Di pa pala mag-stop. Try kong tapusin tong infinite limits before going to the first major theorem. Okay. So infinite limits. So this will just define when the limit of a sub n is written to be positive infinity. Though, again, our understanding is that positive and negative infinity are not numbers. All right. So they are just symbols to denote na palaki ng palaki yung values ng a sub n's or paliit sila ng paliit in the case of negative infinity. So the sequence a sub n is said to diverge to positive infinity. So we either write the limit of a sub n as n approaches infinity is positive infinity, or alternatively, we can write this way. Okay. Intuitively, if and only if habang lumalaki yung subscript, lumalaki rin ang lumalaki yung a sub n. Right? Kasi ang usapan dito si an, palaki ng palaki. So the bigger the subscript is, palaki ng palaki yung mga a sub n's. But again, what do we mean by palaki ng palaki? So we need to quantify it mathematically. And how do we do that? Is to adopt this definition. For every m that you can think of, kahit anong real number, however big it is, there will always exist a subscript, capital N, a minimum subscript, capital N, such that kapag kumuha ka ng mga little n's, lahat ng little n's na mas malaki kay capital N, yung a sub n nagiging mas malaki na kay m. So if you can think of, if for any number, any real number, however big it is, you can find a lower bound or a threshold for the subscripts such that right after that minimum subscript, lahat na ng a sub n's ay mas malaki na kay m. And you can do this for any real number m, then we say that the sequence diverges to positive infinity. Ibig sabihin, lagi na lang yung mga nasa dulo ng listahan ay mas malaki kay m. And imagine you can do this for whatever m, however big it is. So really, the a sub n's grows indefinitely. It grows indefinitely and without bounds. Palaki sila ng palaki. And alternatively, we say that a sub n diverges to negative infinity, again intuitively, kung paliit ng paliit yung values nila. Paliit ng paliit in the sense of paliit na negative numbers. All right? So it is true if and only for any real number m that we can find, however small it is, meaning small taken with its sign, then there will always exist a starting value for the subscripts such that after that starting value, a sub n becomes smaller than negative m. Okay? Or a sub n or negative a sub n becomes larger than little m. Okay? So yun yung idea ng divergence to negative infinity. And you have example 2.5 here. I'll just leave it as a reading assignment. So just make sure you understand the proof of example 5. Okay, let's try to prove a couple of parts of Theorem 2.7. Okay, Theorem 2.7 says, let's consider two real sequences such that a sub n diverges to positive infinity, or respectively, a sub n diverges to negative infinity as n approaches infinity. And we have these four things. So ang limit daw ng a sub n plus b sub n, provided that b sub n is bounded below, ay equal kay positive infinity. So ibig sabihin si a sub n ay palaki ng palaki. Si b sub n ay bounded below. So ibig sabihin pag kinuha ko yung sequence consisting of the sums of a n's and b n's, this will still diverge to positive infinity. Which kind of makes sense kasi si AN ay palaki ng palaki. Si BN, hindi naman siya lumiliit ng lumiliit. So, ibig sabihin, yung sum na to, in the long run, will be a large number. Okay? But question, bakit kailangan si BN ay bounded below? Bakit kaya? Anyone? Aside from those that recited earlier? Bakit kaya requirement na bounded below? Ano yung magiging problema kung hindi bounded below si BN? Ang alam natin kasi si AN nagda-diverge to positive infinity. But why is this condition necessary? Ano yung pinaprevent na mangyari nung condition that the sequence BN is bounded below? Ano kaya yung pinaprevent niya? Anyone? Sige, free for all. Bakit ano yung pinaprevent ng pagiging bounded ni BN? Ano yung pinaprevent niya na scenario na magpapa-false dun sa theorem? I hope you see the idea. Kaya ko tinatanong tong mga bagay na to is I want to train you how to read the textbook. That's why I also preferred writing over the actual textbook para pag kayo na lang yan, tapos nagbabasa kayo ng math books, magkaroon kayo ng idea ano yung magandang way para magbasa. So you always question, bakit kailangan tong kasama sa premise? Ano yung scenario na sinisafeguard niya tayo from? Ano yung pinaprevent niyang mangyari? Okay. So, this condition that Bn is bounded below prevents the possibility that Bn diverges to negative infinity. So, kung si Bn ay bounded below, ibig sabihin hindi siya pwedeng mag-diverge to negative infinity. At ayoko na si Bn mag-diverge kay negative infinity. Bakit? Kasi kung siya ay magda-diverge to negative infinity, posible akong rito magkaroon ng positive infinity plus negative infinity, a very large number minus another large number. And from calculus, that's indeterminate because we don't know which one grows faster, right? So yun yung pinaprevent niya. Ayaw niya na magkaroon ng case na infinity minus infinity. Okay? So let's try to prove that. Okay. So probably we'll start with the prelim analysis. So PA. So gusto natin, we want to show that A sub n plus B sub n approaches positive infinity. So, well, for this to happen, this should be true for all M and R. There should exist a capital N such that whenever n is greater than or equal to capital N, yung A sub n plus B sub n dapat ay mas malaki na kay capital N. Ito yung gusto nating makuhang inequality, right? But what do we know? We know that A sub n converges to positive infinity. So that means we know that we can select the subscripts n to be large enough so that A sub n ay greater than m. Ito yung magagamit natin dun sa actual proof natin. And this m here is arbitrary. Pwede nating paglaruan yung value ni m kasi nasa definition for all m. Now, this is what we have so far. Okay, from our analysis. Ito yung gusto nating marating. Ito yung alam ko. So, pwede ko sigurong gawing tong A sub n greater than m minus B sub n. And this is an if and only if statement. So, pwede akong go backwards. Mula dito, pabalik dun sa given. Remember, yung PA usually working backwards tayo. Okay? Now, I want to force that A sub n becomes larger or becomes smaller than m minus b sub n. And one way to do this is to insert something involving m minus little m, where little m is smaller than b sub n. Kasi yun lang yun pa yung hindi natin nagagamit. Yung assumption that b sub n is bounded below. Since the b sub n's are bounded below, therefore we can find a natural number little m, or sorry, a real number little m, na mas maliit sa lahat ng b sub n. Okay? So what is the relation between big M minus little m and big M minus b sub n? Sino yung mas malaki? Yung may bn o yung may little m? So, nagsusubtract tayo. So, pag nagsubtract ako ng mas maliit na number, ibig sabihin mas na malaki yung difference. Tama? So, this guy goes in the middle. So, pwede kong sabihin, I will force the issue that an becomes larger than m minus little m. Okay? Because if we can force that m minus little m is smaller than an, but m minus little m is larger than m minus bn, then we are done. Okay? Magpa-follow na siya automatically. And then the thing here is that, can we do that? Well, remember that an is greater than m for all m's. We can find an n sufficiently large enough such that this is true. And since m minus m is a real number, I should find a sufficiently large little n na magiging totoo tong inequality na to, which in turn will imply a sub n is greater than m minus b sub n. Tapos babalik ako papunta dun sa gusto nating ipakita. Okay? So it's a play on the definition, taking advantage na for all m, totoo itong inequality na to involving a sub n. And then I can choose m to be whatever I like. Specifically, I want capital M to be capital M minus little m. All right. So let's write the proof. So again, here we assume that a sub n approaches positive infinity, and b sub n is bounded below. So that means there exists a real number m, little m, I mean, such that little m is smaller than all the b sub n's for all n's. Okay? Then also, given m minus little m, because again, m can be chosen arbitrarily. So basta kahit anong real number m, mag-hold in definition ng a sub n greater than capital M. So gawin kong capital M instead of just capital M minus little m. And this is still a generic real number. Kasi ito ay arbitrary minus a fixed value. This is still arbitrary, right? So this is still a real number. So since an diverges to positive infinity, then there exists a capital N in N such that for all little n greater than or equal to capital N, ang a sub n ay mas malaki sa m minus little m. But m minus little m is greater than or equal to m minus b sub n. Kasi nga yung m ay mas maliit sa lahat ng b sub n's. Mas maliit na subtrahend, mas malaki na difference. Tama? So in short, what we have here is that an is greater than m minus bn. And then add bn to both sides to get an plus bn greater than m for any real number m. Kasi si m ay chosen arbitrarily, right? Wala tayong ibang condition kay m, kundi si m minus little m ay real number. M is fixed, so therefore m can be any real number. And this is the exact definition of being divergent to positive infinity. And that ends the proof. Okay? Now, I guess you can do the same thing for part B of the theorem. So I'll leave that to you. Ang gustong ipakita nun ay limit ng CAN as n approaches positive infinity ay equal kay positive infinity. Again, assuming that A sub n diverges to positive infinity. Okay? So I think we'll stop here. Let me see. Parang unti na na-cover ko ngayon, but that's fine. Yeah, sakto lang pala. So that next time we will look at the first grand result or major result about sequences, and that's the monotone convergence theorem, to be followed by the nested interval property, then the Bolzano-Weierstrass property, then the convergence criterion, and you will see that all those four are equivalent to the completeness axiom. All right. Now, before we leave, any questions? Ito pala, nakalimutan kong banggitin kanina. Don't feel bad if you don't understand everything in one sitting, or nanonood kayo ng live session or attend kayo ng live session and not everything is clear. And that's natural, all right? Especially if this is the first time that you are seeing it. It's a big plus if you will absorb, say, 50%. It's already very good if you can absorb fully 50% of the lecture. Because, yeah, maganda ng starting point yon. But don't worry if you are not able to get everything. Kasi nga, hindi ko naman expected na matututunan nyo to in one sitting. Kasi kahit nga nung face-to-face, wherein I think that's more effective than just doing this over the screen, pumapasok ako sa klase, hindi ko naiintindihan lahat ng tinuturo ng prof. And that's what going home and studying on my own means. Babalikan ko yung notes ko and so on. So technically, nung face-to-face, yung 3 hours a week na lecture, hindi lang yun yung time para mag-aral ako ng 155. And that should be somewhat parallelized in the online setup. May advantage pa nga kayo kasi pwede nyo panoorin yung recording pa ulit-ulit. You can pause, you can speed it up, you can play it slower so that ma-absorb nyo ng mas madali yung mga topics, right? Pero yeah, yun yung advantage nyo kasi dati notes lang yung nagiging basihan natin sa face-to-face. Do I understand? Merong kaakibat na disadvantages yung sa work from home or study from home na wala na yung wala na yung boundary between home and school and work. Kasi dati pagka umuwi ako ng bahay, ayoko na nagtatrabaho. Gusto ko lahat ng trabaho ko iniiwan ko sa school. Kahit yung estudyante ako ng PhD, yun yung tinry kong gawin. Pag umuwi ako ng bahay, hindi na ako nagtatrabaho. Gusto ko na mag-relax. Okay, mag-YouTube na lang ako, mag-Netflix na lang ako. So, pero ngayon ang problema, nasa bahay tayong lahat maghapon, dito na tayo nag-aaral, dito na tayo nagpapahinga. So parang wala nang division, no? Tapos marami pang distraction. And of course, we still have the pandemic. So there are some instances wherein there are our family members or we ourselves are having some difficulty. So yun yung mga balancing acts na ginagawa natin at this particular moment. That's why I always encourage you guys na wag lang yung 3 hours a week yung gagastusin natin sa Math 155. But again, I know not everyone can afford to study more. Lalo na ngayon na nasa bahay tayo, maraming external factors. There's the pandemic. So if you think you cannot really, that you cannot really fulfill the requirements on time, just let me know at ano yung reason, then I can give you some accommodations. But as much as possible, let's try to stick to the deadlines that we agreed on. All right? So, but just let me know. I can be as flexible as you need. Basta sabihan nyo ako. All right? And again, the deadlines are given para meron pa rin, para ma-satisfy pa rin natin yung minimum requirements ng course. But I don't want in the process na mag-suffer yung physical or mental health nyo. But I will not know if you will not let me know. Okay? So please keep the communication lines open. Kung may mga problema talaga, just let me know. Tapos pwede naman kayo mag-haggle with me about the contents of the problem sets or the homeworks if they are really too much. But again, please let me know, all right? So with that note, I'm done. tapos na ako for today. How about you guys? By the way, yung mga nag-recite pala, paki-comment dun sa meeting chat. I think si Carlo hindi pa member, so I'll write her name here. How about the others? Meron pa bang hindi member ng teams na nag-recite? Kung wala na, paki-comment na lang dun sa meeting thread, yung pangalan niya, para ma-record ko siya mamayang gabi. But other than that, any other concerns, questions? Okay, so if none, then thank you for coming today. I hope you enjoyed the rest of the night, and let's see each other again on Thursday. Bye, everyone.
Thank you.
Salamat po, sir.